look at quadratics and how to solve quadratics. But in these questions, you'll notice that there isn't just a 1 in front of our x squared term. So our method changes slightly to what you've been using before. So our aim is to try and get this into double brackets and then solve. However, we're going to take a couple of different steps to begin with. So in this question, because the number in front of the x squared isn't 1, we have to work out the product of a, c. And if we look up to our general quadratic, you can see a is the number in front of the x squared, c is the number at the end. So 2 times negative 20 is negative 40. So now we know we're timesing to make negative 40, and we are adding to make our b, which again, if we look at our general quadratic, is the number in front of the x, which is 3. So now we can write down our factor pairs of negative 40. Bear in mind, we are trying to get them so they've got a difference of 3. We know negative 8 times positive 5 gives you negative 40. However, that adds to give negative 3. Negative 5 times 8 gives you negative 40, and they add to give 3. Remember, you could have written other pairs like negative 40 and 1, 20 and 2, and so on. However, there's only one pair which is going to work. Once you've worked out that pair, you now need to rewrite the quadratic, but instead of writing 3x, you're going to write your 2 answers. So you can see here our question hasn't changed because negative 5x plus 8x is exactly the same as the 3x. We've just changed the way it looks. Our next step is to split our quadratic in half and factorise each side separately. So we're going to factorise these into single brackets. You can clearly see that there is a common x in both of our terms. That'll leave us with 2x minus 5 inside our bracket. If we do exactly the same for the other side, we can see that there is a common 4 in our terms. 4 times 2x gives you 8x. 4 times negative 5 gives you negative 20. This is your first check. Your brackets should be identical. If they are not identical, something has gone wrong. So check how you factorised and check you factorised fully. Now we know we've got x lots of this 2x minus 5 brackets plus another 4 lots of this 2x minus 5. In total, we would have x plus 4 lots of this bracket 2x minus 5. Our 2 terms, which are outside the bracket, come into this first bracket together. Now we solve it like before. So we put each bracket equal to 0. That will give us one solution of negative 4. And our second solution of 5 over 2, or 2.5. And you've got both of your answers for this question. Our second question, again I'll talk through the process. So we've got to times to make a c, which in this case is positive 6, and we're adding to make b, which in this case is 5. So we write down our factors of 6 and we select the correct one. We rewrite our question out, but using the 2 answers listed above. You can see that our question hasn't changed because 3x plus 2x is exactly the same as 5x. We've just changed the way that it looks. We now split our quadratic down the middle and we factorise each side. This time we can see that we can take out 3x. That would leave us with x plus 1 in our bracket. And on our next one, we can take out a common factor of 2, which again leaves us with x plus 1. Again, now we check this. Our brackets have to be the same, otherwise something's gone wrong. They are the same, so now we combine our brackets together. We've got 3x lots of x plus 1 plus another 2 lots of this x plus 1. So in total we have 3x plus 2 lots of this x plus 1. As it's only asked us to factorise, we have completed the question. Question 3, again, is very similar. We're timesing to make a c, which in this case is 6 times 4, which is 24, and we're adding to make the b, which is 11. Again, we write down our factor pairs of 24. Again, you'll notice that only one of these pairs works. So we rewrite out our quadratic, but with our two answers we have just found. Doesn't matter which way you write it, you could have rewritten this as 6x squared plus 3x plus 8x plus 4, or the way I've shown you. We split our quadratic in the middle, factorise each side carefully and separately. So we've got 2x common in both of these. Our highest common factor is 2x. That leaves us with 3x plus 4 inside your bracket. And you'll notice this is the same as what we've got on our right hand side. So actually, when we factorise this, we just need to take out a common factor of 1. Our brackets match, so now we can combine our bits of information together. We've got 2x plus 1 lots of this bracket 3x plus 4. Again, it hasn't asked us to solve, it's only asked us to factorise, so we finish there. Our fourth question again follows the same method. We're timesing to make it AC, which in this case is 10 times 6, which is 60. And we're adding to make our B, which is 19. And now we write down our factors of 60. Again, there are quite a lot of factors, so if you think about this carefully and think about factors which have a difference of 19, you'll get it a lot quicker. So 4 times 15, 2 and 30, and so on. And you'll see that we've got it on our second one. 4 plus 15 is 19. Now we rewrite our quadratic. So we have 10x squared plus 4x plus 15x plus 6. We split our quadratic down the middle and we factorise each side into single brackets. So we look for our highest common factor in 10x squared and 4x, which is 2x. That leaves us with 5x plus 2. And we do exactly the same on the right hand side. Here you'll see that they've got a highest common factor of 3. That'll leave you with 5x plus 2. Double check it, your brackets are the same, which they are. That means we've got in total 2x plus 3 lots of this 5x plus 2. Again, it's only asked us to factorise, so we have finished there. Our fifth and final question, we're timesing to make AC, which in this case is negative 36, and we're adding to make B, which in this case is 5. We know to times to get a negative and add to get a positive, one of the numbers must be negative and one must be positive. So now we write down our factors of 36. So now we need to rewrite our quadratic using our two numbers we've just found. So 4x plus 9x minus 12. Split our quadratic down the middle. Factorise each side separately. Just double check your brackets match. And we put together our x plus 3. And that's all times by this 3x minus 4. Again, it's only asked you to factorise, so you have finished the question there.